Okay, good morning, good afternoon, and good evening. My name is Victor, and I'm going to be your anchor for this session. Also, I'm going to be looking at data science. So what is data science? So I have a few slides, very short, 15 to 20 minutes session. I want to anchor on what data science is, how to get started with data science. So if you're a new subscriber, thank you for subscribing. Do well to share. If you're new to the channel, do make sure you subscribe. And I'm going to be looking at data science. I'm going to be doing video presentations on Python, on R, on SPSS, on quite a whole lot of, on Google Data Studio, Tableau, Power BI. It's going to be a very long journey. So we're going to start from the very basics. So in this session, I'm going to be looking at data science. What is data science? So a lot of persons want to get into data science. A lot of persons want to get into trying to analyze data. A lot of people want to get into trying to make sense out of data, out of CSV files, out of Excel sheets. The question is, why do we need to learn data science? Now, because we need to provide intelligence, because we need to provide insight. When I say intelligence, what do I mean? Imagine having 1,000 persons in a stadium, right? There is no intelligence. There is no insight from just saying, I have 1,000 persons coming to the stadium. What about if you say, I have 200 males? What about if you say, I have 500 females, I have 300 adolescents or kids? You see, you've not made the data better. So you're not trying to provide information. What about if you say, I have 200 adults aged between so and so. Then I have octogenarians. I have persons above 80 years, aged between so and so. I have kids aged under 5. You see, you're trying to explore the data. You're trying to analyze the data. You're trying to get some insight from that data. That way, you are going to be able to get better information. That way, you're going to be able to better plan. That way, you're going to be able to better organize that particular football event or whatever. So one of the reasons why we need data science to be able to make decisions. If we don't explore data, if we don't get insight from data, we won't be able to make decisions. So look at it. If you want to get into data science, it then means that you're interested in helping executives, C-level executives, that's the CEO, the CFO, the Chief Financial Officer, the CTO, the Chief Technology Officer, and all of those top-level executives. You want to be able to help them analyze data, then make decisions. So if they're able to make decisions, there is what we call the data science process. So to do data science, you need to follow some certain process. You don't just start making inference from data just that way. So it follows through a process. So, and there are several models to that. So we'll pick this one. This is just an image that helps us explain how do we come about getting the data and deploying that data or trying to make intelligence from that data. So it starts from data collection. It then means if you need to, for instance, the case study I gave, if you need to make intelligence from that data, if you need to make decision from that 1,000 persons coming to the stadium, you first need to collect the data, right? So the question is that how are you going to collect the data? Are you going to count? Are you going to do count? Are you going to tell them to fill a form? Are you going to submit a questionnaire? You're going to do something to collect that data. So data collection is the lowest level in the data science process, but very, very critical, very, very important. So some people starting up in their career start up with just data entry officers. They start up with a field collection agent, the field officer, questionnaire, maybe design or standardization officers and whatever. So just collecting that data. But that is very critical as we move on in this journey in the channel, because I'm going to be releasing several videos that has to do with data science, machine learning, artificial intelligence, and the rest. You will see that if you don't collect data properly, it affects your entire model. It affects your insight. It affects your graphs, affects your all of the things you're going to be doing later on. So data collection is very critical, and that is the very first stage. Then you have data cleaning. At times you can have missing data. Imagine you say 1,000 persons coming to the stadium, fill in your name, your age, your gender, your maybe health status or whatever. Somehow some persons are not going to fill some stuff. Some people are going to put wrong data. Some people are going to mean something and fill something else. The person even entering the data at times might take, for instance, what is your age? The person thinking they're asking you, what is your height in meters or centimeters? So the person enters 500. So thinking he was saying, what's your age? What's your age? Of course, you know, somebody coming to the stadium should not be more than, let's say, 100, for instance, 100 years of age. So, but you now, you're entering 500. So there is problem with that particular observation. So what the data engineer is going to do is to try to clean up the data and standardize the data so that it doesn't affect when we start plotting graphs, doing analysis, trying to do some machine learning models and the rest. So the data engineer takes care of that, right? Collection, you clean it up. Then EDA, what we call exploratory data analysis. So if you want to get into data science, one area that you're going to find yourself doing is not just creating questionnaires, standardizing them. There's a tutorial I have on that, on how to create questionnaires, standardize them, and you're going to enjoy that. So please stick to the channel, make sure you subscribe, and make sure you invite your friends that are interested in starting a career in data science. Now, after collecting the data, the next thing you want to do is to clean it. Once you've cleaned it up, next you want to start exploring the data. When you hear the word EDA, exploratory data analysis, what you're trying to say is that you want to explore, you want to understand, you want to better know that data you collected. So most of the times, the data analyst does that. So what are the kind of things he's going to be doing to try to understand the data? So he's going to be doing things like bar chart. For instance, if I do a bar chart of the number of persons coming to the venue at different days, it can be able to help me tell which of the games in the stadium that people prefer to attend. You see, I am exploring the data, things like count, how many of the social persons, average, sum, medium. All of these are what we call central tendencies, your average, your standard deviations. All of these things will help you better understand the data. For instance, if you have a school intake admission of 100 students, you've collected the data, you've cleaned the data from the forms, the field. In exploratory data analysis, you try to answer the question by saying, what's the average age of student intake? You're trying to answer the question of saying, at what time of the year do you have much intakes? Is it at the maybe January intake, or is it the September intake? Or you might be asking the question, in which of the courses do we have more students trying to gain admission into whatever department or faculty? So that way you can see that, okay, many persons want the physical sciences, or many people want the humanities, or people prefer, let's say, the medical sciences. So if you don't explore the data, you won't understand the data. So that's one of the jobs the data analyst does. Now, the next thing you do is model building. So what do you call the model? How many of us have, you see an architect, for instance, if an architect is to design or build a 3-bedroom flat or a terrace duplex, One thing that the architect is going to do is going to sketch it up, then he's going to design it, he's going to put it into a 3D model, and at times he's going to do like a mock-up. He's going to model something that looks like that building, that looks like that stadium, that looks like that estate. That way, you better understand what you're dealing with. And from that, you can extrapolate, you can forecast, you can make decisions on something bigger. It gives you full understanding of the data. It gives you, there you're checking trends, there you are checking similarities, there you are checking relationship, right? So we're going to be looking at machine learning, look at some algorithms like the k-means, the random forest, the linear regression, logistics regression, quite a lot of machine learning algorithms we're going to be looking at later on in this course. But at this point, we're just trying to say, we've understood the data. What about if we create some models that are able to help us forecast? For instance, since we now understand that people prefer to watch football compared to other games, how about we trying to forecast to see what will be the number of persons by a so and so, all things being equal? So you see, at the process, at the time where you're doing model, you're trying to actually check into the future. Here in exploratory data analysis, you're trying to look at the past, what you've collected. Then while trying to build a model, you're trying to look at the future. Then when you deploy the model, that is where AI now comes in, artificial intelligence. So in artificial intelligence, you are saying you no longer want to rely on these data, or come again, run exploratory data analysis and machine learning. But rather what you want to do is that you want to deploy this model you've created so that it can now henceforth take decisions for you. So that is AI, artificial intelligence, because the intelligence is no longer you, it's now your data taking care of, what was it called? Decision making for you. So that's where you have AI, you have robotics, and you have the rest. So this is what we call the data science process. So you have data engineers working at this level, data analysts doing majorly exploitative analysis. They have machine learning engineers trying to create models, optimize the data, make their model better. Like just 2 days ago, we tried creating some negative binomial regression for a particular project. Then we started getting level of accuracy of, say, I think we're getting like 70-something%. We had to try to start optimizing the model, try tweaking the model, so that I think as of today, we were able to get up to 90-something%. So that model, if you deploy that model, it then means that that model will be able to make forecasts for the future, and it's always accurate. Okay, process of data science. So I've talked about data collection, cleaning, exploratory data analysis, model building, and model deployment. Now, there are some frameworks that talk about how do you do data science, how do you get into the field of data science. So there's this guy called Hilary Manson and Chris Wiggins. They introduced what they call the OSEMN framework, right? It's just a taxonomy, tells you if I want to do data science, I obtain the data, I scrub it, which is synonymous to me cleaning it up, me making sure that there's no outliners, or there's no, even if I have outliners are like, for instance, you collected data of kindergarten pupils. Now, while entering the data, you find out that there's one data point that have age 50. That's very rare. So that is like an anomaly. You don't want to have your data set having that kind of point, because what's going to happen is that if you want to start creating a model, this model is based on the data that you have. So that is why it is important you clean up. Then, of course, you explore, you model, you interpret the result. This is where you're not going to be presenting the data. So as a data analyst, you've not done your job if people cannot make insights, if people cannot get intelligence from your analysis. So data science is not just about using a tool or just plotting graphs or whatever. Question is, What meaning can we make out of whatever you've done? Okay, so this is what it looks like, right? Just listed it out very well. So we obtain, we clean, we visualize. So at the point of exploratory data analysis, we're going to be visualizing. That's where we draw graphs and pie charts and bar charts and spike lines and the rest. So M will model, then we interpret the data. Now, the question is, how do we obtain our data? I'm going to be running a small course on, I talked about questionnaire design. I also consider something on data entry, data collection. Because you see, you need to understand how to collect your data, because the question is that your data is going to come from several means, several medium. Now, at times, later on in this short presentation, we're going to look at what tool do I use if I want to get started in data science, right? So the question is dependent on how you're going to obtain your data. Is it going to come in CSV? Is it going to come in JSON? Is it going to come in extensible markup language? Is it going to come in SQL file? Is it going to come in what format is that data going to come? So you cannot do anything as a data analyst or a scientist without having any data. So if you have questions, don't forget to make a comment in the video, and don't forget to subscribe, because I'm going to be bringing up follow-up content with respect to all of the things I'm considering. Now, some of the skills you require is database management, though not compulsory, depending on what sector you're going to work in, what part of the team that you're going to be working with. Now, here, for instance, if you have an e-commerce website, that e-commerce website is going to have a database, and somehow they would have used either an open source or a premium database management system. So these are all open source: MySQL, PostgreSQL, MongoDB, or they might be using Oracle or MySQL Server. Whatever type of database management system they use, they're going to have somehow SQL file as export of the data they have within that database. So basic data manipulation skills, database management manipulation skill is very critical, is very important. So that's why you need that skill to be able to do inserts, do cleanup, do joins, do of course export your data set from your database. Or if you have a different team handling that, it then means that they are going to export data for you in this format, in CSV, JSON, XML, SQL. Then you can now proceed to analyzing your data. And your data is good to come sometimes in text, in video, in audio files, in documents. For instance, if you are doing language processing, your file can come in text file where you need to now read the file, make interpretation, or it's going to come in other several formats. At times, if it's coming in cloud-based platforms like the Amazon Web Services or Google or whatever, at times they can be using distributed storage. When you say distributed storage, you mean where your file is not going to be processed, or rather where your file is not going to be stored in one place. So that's where Hadoop, Apache Spark, Flink comes in, right? Because your data is not in one hard disk, or for instance, or in one hosting account. So that's where cloud computing comes in. So understanding this helps you in the data science, especially if your company, if your firm, or as a freelancer, if you are going to work with persons that have their data in the distributed format. So the next stage is cleaning your data, right? So what are we going to be doing? We're going to be identifying errors. If we have the 1,000 persons coming to the stadium that filled the form, we want to see, where do we have errors? Where do we have missing values? Where do we have corrupt records? Where do we have records that looks like an anomaly, that looks like it's just impossible for me to have this particular record? So that's what you do at this stage. You clean up, you throw away that data or that line, especially if it's not much. For instance, if you have 1,000 entries, you cannot be throwing away 300 items you want to go back and see if you can correct that, because that's quite large. But if it is, let's say, between 5 to 10, 15%, you can do away with it, right? You can throw those entries away, because it's going to affect your model later on if you're going to create that. Then you can decide to replace, right? Replace and or fill missing. You can use them interchangeably or use them in this format. For instance, you could take, let's say, age of students in first year in the university. So you have few missing data, for instance. What you can do is that you can take the average of the entire students, then you fill it into those persons that didn't fill their age. So that's one way you can handle missing data. So there are other several ways. We're going to look at them when we start using data and start using actual data and do some of these things. So the skills you require is any of this tool will do that for you, or any of this language. This is a library. Pandas is a Python library. We're going to be looking at Pandas, Matplotlib, Seaborn, and quite a lot of them. I'm going to be starting the Python data science recording very, very soon. So make sure you subscribe to the channel and keep to date. Now, of course, you have these scripting languages like Python, R, and SAS. Now, distributed processing. If you're going to be doing cleanup, it might be good you understand how to use these distributed processing platforms. So when we say distributed processing, what we mean is that the data is not being processed at one point, but across platforms, across different points. Then the next stage is where we're going to be doing exploratory data analysis. Here, we just want to visualize. So I'm going to be using NumPy, Matplotlib, Pandas, and when I do the R programming data science course on the channel, I'm going to be using ggplot2 and DeepLRY. YR, then of course you need data visualization skill set, because at this point, if you plot the graph of the data set, you will better understand the data set, right? If you don't plot, if you're just looking at numbers, you might not actually understand the data set very well. Then machine learning. So this is a very fun part. Now, this is very heavy in statistics, but I'm going to make it very, very simplistic for you. I'm going to be explaining the different machine learning algorithms, when we should use them, how we should use them, and I'm going to be using some data sets to actually code them so that you can actually follow. And whenever you have a machine learning program or problem, you can pick a methodology or a language, then of course you can run your model. So this is very in-depth in terms of analytics. Then here you're trying to create something that is going to predict your future, like I said earlier on. Skills required: supervised and unsupervised algorithms. I'm going to be looking at them in the separate recording. We're going to be looking at all the different types of machine learning that are categorized as supervised learning. I'm also going to look at those ones that serves as unsupervised learning. So this is more or less like an introduction for you to understand what the data science process is like, what kind of skills are you going to be needing, what I'm going to be training you on, and how to get started. Storytelling. Now, no matter how you collected the data, cleaned the data, visualized the data, created a model for the data, you need to be able to pass this information. You need to be able to tell a story. You need to be able to properly visualize and tell executives, tell whoever is going to need this data so that they can make decisions. The job of a data analyst, a data scientist, is to help people make decisions. Once you cannot do that, you have not done your job. Tell the story, help people understand, help people see intelligence from data. Okay, so here visualization is very key. Tableau, Matplotlib, D3.js. This is a JavaScript library. I've used it a few times. I've also used the chat.js. These are all JavaScript library for visualizing your data. Very fun to use. Then you have Seaborn. Then communication skills. If you want to be a very good data analyst, you should be able to pick up data, analyze it, and tell people what that data is saying. Data don't lie. And we see data is the new oil. So if you need to pick up data, analyze it, you should be able to write very basic, simple reports, right? 2, 3, 4, 5-page document, a dashboard, create a dashboard, put all of your charts, your spike lines, your pie charts, your whatever, and tell people about the data, right? Be able to convince them. Now, data science has a large landscape. Some people find data science as an escape route from hard coding, right? Yet you can be right and you can be wrong. But you can choose what aspect of data science that you want to major in, right? Like you see, this is data science, right? You could focus here, you could focus here, you could focus here, you could focus here, you could focus here. So you can decide to be a data engineer, you can decide to be an analyst, you can decide to be a machine learning engineer. So you all start from just being data engineer. Just pick up data, design questionnaires, put them to the field, collect them, clean them, make them ready for the analyst to start working on, right? So it's a very large landscape. So you have data pre-processing, you have software engineering, where you're going to be doing all of this. I won't have time to, I want to make the video very short. I'm going to come later on and pick up each of these concepts and give you heads up, then pick up data sets and try to work on them so that you see how these things work. So you have machine learning, you have data visualization. At times we say data science is at the heart of computer statistics. And what was the last one again? Computer science and mathematics. I have a first degree in mathematics. I understand that at times people don't want to talk about numbers. But you cannot do data science without numbers, because numbers tells us everything. Computer, for instance, is just zeros and one. And you can't talk about data science without using your tools, your softwares. That's where computer science, being able to use tools and software, that's where they come in. You cannot talk about data science without talking about statistics. So data science is just typically statistics, mathematics, and computer science. So, but here on a very lighter note, we're trying to pick up data and make sense out of it. There are several tools we could use: Python, Tableau, Excel, SQL, R, SAS, SPSS, Matplotlib, Stata. Now, most of the times I hear my students asking me, which tools should I learn? What is the best tool to use in data science? Now, the point is that there is no best tool. In the channel later on, I will do a short video and explain each of the tool, why you should use the tool, when you should use the tool, and what each tool is best at doing. I use most of this tool. I use Python, Tableau, Excel, SQL, R, Matplotlib, SPSS, Stata. I don't use SAS, right? But the rest of this tool, I use them very well. In my day-to-day job as an analyst, analyzing data, doing feasibility study report, at times doing business development, at times doing business analysis. If I need to pick up data, if I need to analyze those data, if I need to help people to make inference or maybe businesses and whatever, the point is that I will need to use one of the tools at some point in time. But there are times that some kind of job you want to do, Python is going to be your best bet. That some type of jobs you want to do, Power BI is not listed here. So Power BI is another tool also. It's a very fun tool by Microsoft. It's called Microsoft Power BI, Power Business Intelligence. So I will do a separate video on the different tools and when you should use them and how you should use them. So there's no best tool, but you could start from one. And the fun part is that once you be able to use up to 2 to 3 tools, you can always teach yourself the rest of the tool. Because the goal of a data analyst is not typically to just learn how to use the tools, it's to learn how to make decisions, right? So the tool is just one component. Being analytical, being creative, being able to communicate, being able to understand the data analyze it, create a model with the data. Now be able to give inferences from data is very key. How do you start? You need to figure out what you need to learn. You need to be comfortable with any of the tools. Must be Python, must be R, must be Excel. Just be comfortable with one of them. Be able to do data analysis, be able to manipulate data, be able to visualize it, either with pandas or any of the tool. This is a case study of Python or R. Be able to do machine learning with any of the tools. Any of the tools can do machine learning. If you're using Python, then Scientific Kids Learn is one of it. Just keep practicing, right? Start up an internship. Try to get freelance roles. Try to get a job. Try to be able to work with data. Keep practicing and you're going to be your best. Now, you could apply data science to several fields. I've used data science in analytics, business intelligence, like I said earlier on. I've used data science in finance. I've used data science in environmental science. That's why I'm going to be teaching you Kobo. Kobo is a tool you can use for, there's another tool also called ArcGIS. You could use that to do geographical plotting. For instance, if you go pick up data from remote areas, you could plot it on your map so that you could make decisions on how the data you have collected is being represented. I've used data science a lot in cybersecurity. This is one of my strengths because, for instance, how will an antivirus software, for instance, tell that this is a threat or this is an anomaly or this is a spyware or this is a Trojan or this is a whatever. So you talk about heuristics, talk about AI, talk about all of that. So they're all based on data. So several areas. So there's no limit. I've trained medical doctors, doing research, doing a lot of stuff in data science. So data science, it's what we call the new guy in the town. So you can apply it to typically every field. Okay, so you should be able to learn how to get data. I'm going to be looking at Kobo Toolbox later on. I'm going to be looking at Google Form, how to create Google Form or use Typeform or Microsoft Form or whatever kind of form, how to create that. Then how to do observations, create questionnaires or interviews or documents, how to run some tests. Then when the data is being collected, it's going to come in Excel or it's going to come in SQL. Then how do you now explore the data, compile it, store it, be able to use it maybe later on in the future or plan with it. So you're going to be seeing something like this, right? This is like a dashboard. So at this point during your presentation, you want to be able to tell your audience, okay, this is this. These are the top 5 directors by Facebook likes, right? You could see it is sorted out. These are my line charts for this and this. So you are giving insights, right? And the good thing is that if I tap on this, I could reorder this item by any of the genre, by action, by adventure, by comedy. This is a dashboard. We could use this. We could use a Power BI. We could use Tableau. We could use Excel. This on its own is Excel, right? This is Excel also. Okay, thank you very much for watching. This is an introduction to what data science is. Understand it's a process. The goal is you want to be able to provide insight and intelligence. Don't forget to like, don't forget to share, and see you in the very next episode.